Hi, this video is going to be highlighting the important features of making scatter plots from a set of data from basically experimental data, which won't necessarily form a perfectly straight line like we've seen in the past. If we're plotting points as we substitute in independent values for the independent variable in an equation, and the equation is a linear equation, then you'll find just a perfectly straight line anyways. So this video is going to be using experimental data, as we can see here, and we'll just kind of highlight some of the important features of scatter plots, and then we'll move into lines of best fit and predicting from using the scatter plot. Okay, so here we've got some data of some grade 9 boys and their fathers, their heights, and they're all in centimeters. Now, this, so in a horizontal table, the top row is generally the independent variable, and the bottom row is the dependent variable, where if we have a, whoops, that's not really good. In the vertical table, the left-hand column is independent, and the right-hand column is dependent. Okay, so they're always set up in the same way. Now, in my estimation, in my very humble opinion, I would say that perhaps the height of the father should be the independent, because the father comes first, and then the son comes after. So the son's height is more or less dependent on the father's height. Okay, so I would have put the father's height in the independent row. However, the way it's set up here, I'm just going to follow along the process of using the top row as independent and the bottom row as dependent. But that's just, anyways, I'm not trying to be critical. I'm just saying that's the way I would see things if I were setting up the axes myself. So we've got the independent variable up at the top. We've got the dependent down below. We always need a title, so I would say this would be heights of grade 9 boys and their fathers. Sorry about my penmanship, but just sort of wanting to sort of get to the math part here. And then we need labels for the axes. So this would be the height of fathers. Oops. And that's in centimeters. And then we've got the heights of sons down here, and those are in centimeters as well. Okay, and so now here's the thing about using scatter plots. The tricky thing is, notice that these values aren't going up. They're not increasing, and they're not increasing in any sort of consistent fashion at all. So the dangerous thing about this is we cannot write these values, 164, 168, etc., or these values for that matter, the dependent values, we can't write those as the scale on the axes. The scale has to be consistent, it has to be uniform, it has to have equivalent spacing between values, etc., and then we plot these points on afterwards. Okay, so the important thing is we want to see, first of all, what's the lowest value in the top row, or for the independent values, and I see here it's 148, so that's the lowest value. And then we want to see what the highest value is here, and I see the highest value is going to be 187. So to set up the scale, so your points are going to be distributed somewhere between 148 and 187. Okay, and so generally, just to kind of get an idea, we want to go from 187 to 148. So that's around, well, that's exactly 39, but it's around 40 units from the smallest to the largest. Okay, that's where the range of the data is. And then if we look at the dependent variable, we see that the highest value here that I'm seeing right here is 192. And then the lowest value, here's 165, 164. Okay, so 164 here. Okay, and so I see that's going to be a difference of 28 value, or 28 units. Okay, so it's approximately 30. So generally what you want to do then is you want to be taking these 40, the 40 units, for example, and you want to see how your spacing is here, how many grid lines there are along here. So we got groups of 5s, there's 5 here, another 5, etc. So you could sort of distribute those 40 units equally along this x-axis, the independent axis, and you could take these 28, or basically 30 units, and distribute them evenly among these. You know how the grid's set up like this. Now, the danger is sometimes you have to be kind of careful of how you set things up, because you want to have the data kind of mean something, right? You want to look at it and say, okay, I can kind of see there's a trend there. There's kind of like what's happening when we look at the heights of the fathers and the heights of the sons. Can we see any kind of correlation between them? Is there any sort of relationship between those points? So I'm going to show you a couple graphs where the scales are not done very well. And so here's the first one. And so here are all the points plotted, but notice that you know, the horizontal scale is going from, well, 0 basically up to 350. And you know, that width of data, the width of data, like I said, was about 30 or 40, I guess. So there's around 40 units worth of data there in a very small space. So this, you know, even though it does show a relationship, it doesn't really show a true, like a really true bearing of the relationship, or of the correlation between the two data. And we see that these 30 units of data is spread very far here. Okay, so that, I would say that's not really the most effective way to set up a grid in this case for this data. Then if we move along, if I change, so I plotted the same data again, and but this time I put in a scale break. So there was a scale break in here that went from 0 up to this, I guess, well, there's 160, but 162, I guess. And then, so if I were to draw, now, so here's another thing that we're going to be getting into after we plot the points, is we want to draw a line of best fit. And a line of best fit is basically to show the general trend of the data. It's supposed to kind of show like the average of all the data all the way along the scope of the data. So what we want to do when we draw a line of best fit is we want to kind of make sure there's the same number of points above and below the line all the way along the length of the line. Okay, so if I'm going to draw this, I'm going to say, okay, well, does that show a good sense of the line here? Maybe have to adjust it. So maybe I'll go like this, and then I'll bring up this back end a little bit here. So maybe that might be roughly, I don't know if it's up like that. So roughly we see we've got, you know, even though they're not all the way along the length, we've got 1 here, we've got 6 points down below, then we've got 5 points up above over here. So it's roughly kind of showing the trend of the data. Now, the only other thing here is that if you extend that, suppose we want to find the equation of the line, and we're trying to find the y-intercept from where the line crosses the y-axis. Well, if we were just to continue, if we were to lengthen this line, more or less the way we're seeing that we're running out of space here, and this line cannot cross the y-axis. So this is another little danger of setting up the scale where it's too tight horizontally, and we've got the points down below here. Okay, so it's not bad, but in order to find the equation of a line, if we're trying to see where the line crosses the y-axis, this scale, the way I've set it up here, won't work. Okay, so I'm going to move along here, and I've put the data again, and here there's a scale that I think will give a pretty good basis for the points, give a good relationship. Now, again, I'm putting in a scale break, and you have to make sure you put a scale break if you're going to use a scale break. You don't have to, but if you're going to use a scale break, you have to make sure you break it on both axes if you're going to do that. And so here's 0, and then we broke the scale, and then we're starting at 120. And notice that the scale is uniform. We've got 5 spaces here from 120 to 130, another 5 spaces from 130 to 140, etc. And then up the side here, we've got this 1 space, but that's the scale break. And then we're going 1, 2, 3, 4 spaces from 100 to 120, another 4 up to 140, another 4 up to 160. So they're all evenly spaced as well. Okay, so you just have to make sure that it's all even spacing and uniform. Okay, once you've set up the scale, then you can start plotting your points. Okay, so we got 164 and 171, and so 164 is around here, and 171, 164, 171, I would say is around here-ish. Okay, so there's the first point. And then we've got 168 and 186. 168 is here. 186 is not above 190, so I would say it's around here maybe. Okay, so you're kind of estimating, but you're trying to do the best job you can in estimating as close as possible. There's 150 and 164. So 150 is along the x-axis, 164 is up here, so that's 170, just below 165. So that point will be right there. And then we just continue 162 and 180. I'll just do one more here. 162 is here, and 180 is up here. Okay, so that's how you would plot the points. And after you plot the points, then you end up getting a graph that looks something like this. And notice that it's we've got our scale break on both axes, and we've got a nice distribution of points here. We can draw a line of best fit, and remember that what we need to do is we want to make sure that the line goes through as many points as possible, but it doesn't have to actually go through any points as long as it's giving an average, to show the trend of what's actually happening with the data. So I'm going to go up here. I'm going to say this is going to be something like this. And you can extend the line. There's no problem about that. I'm just going to go here, and then I'll extend this actually to the y-axis. So it's maybe around there-ish. So the important thing is not, I mean, you want to draw the line of best fit the best you can. There are mean fit lines where you would find the mean point and then draw your line through that point. That's kind of the balancing point. But in this case, I'm just going to draw the line of best fit with my eye. And then what I'm going to do is, like, the important thing is that now any predictions or estimations I make from the graph, it has to be consistent with the line I've drawn. Okay, so as long as all the information is consistent with this line, then we're good to go. Okay, and I'm going to come back to finish off this video in part 2 when we do a little bit of analysis with this.